The James Webb Telescope's surprising discovery. A challenge to modern cosmology, opening one of the most influential voices in science today, Dr. Michio Kaku, has weighed in on a discovery that could fundamentally change how we understand the universe. A theoretical physicist of international renown, Kaku is celebrated for making complex scientific ideas accessible and for helping the public grasp the strange and beautiful nature of the cosmos. Now, he's turning his attention to what could be one of the most profound revelations of our time, an extraordinary finding by the James Webb Space Telescope, JWST. This space observatory has detected 6 massive galaxies that appear to have formed in the earliest epochs of the universe, much earlier than current theories allow. Their existence raises serious questions. Are our models of the early universe incorrect? Could the timeline of cosmic evolution be far more complex than we believed? Who is Dr. Michio Kaku? Dr. Kaku is no stranger to controversial scientific ideas. As a co-founder of string field theory and a vocal advocate for unifying the forces of nature, he has always shown a deep openness to emerging theories and new data. Unlike some conservative thinkers in the scientific establishment, Kaku is not resistant to bold, disruptive findings. Instead, he encourages skepticism but also curiosity and courage in the face of paradigm shifts. The discovery of the universe breakers. So what exactly did the James Webb Space Telescope find? JWST, the most powerful space telescope ever launched, recently observed 6 massive galaxies that existed just 200 to 700 million years after the Big Bang. These galaxies appear to be mature, massive, and full of stars, more stars, in fact, than our entire Milky Way galaxy contains. The galaxies are so large and evolved that they have been nicknamed universe breakers, because their very existence threatens to overturn key assumptions in cosmology. According to our current understanding, the early universe was a chaotic, hot, and dense environment. Galaxies should have taken hundreds of millions, if not billions, of years to organize themselves and reach such massive scales. Instead, these 6 galaxies appear to have formed and matured incredibly fast, right after the cosmic, dark ages ended and light began to travel freely through space. Why this is a big deal? These findings have stunned scientists because they don't align with the Big Bang model as we currently understand it. According to this dominant theory, matter in the universe cooled over time, forming atoms, stars, and eventually galaxies in a gradual and predictable sequence. Under those conditions, galaxies this large should not have been able to form so soon. Their sheer size and brightness suggest an extreme rate of star formation, hundreds of stars per year, far surpassing our own galaxy's star-forming activity. This could mean that the first galaxies were far more efficient at forming stars than we previously thought, or it might mean something even more dramatic: that our entire cosmic timeline needs revision. Kaku's perspective on scientific revolutions drive. Kaku isn't surprised that a discovery like this has caused such a stir. He reminds us that many scientific theories, no matter how widely accepted, are still theoretical models, not eternal truths. In his words, there are many examples of old and false theories that stubbornly persisted because of the prestige of some scientists. Many of these theories were only discredited when a crucial experiment revealed their falsity. Kaku believes this is a healthy part of the scientific process. It is through observation and experimentation, not tradition or consensus, that science progresses. And right now, the JWST is giving us data we never thought possible, data that might rewrite our cosmic history. The implications of this discovery go far beyond astronomy. They challenge our ideas of space, time, and the nature of the universe itself. They force us to ask fundamental questions. Is our timeline of the cosmos wrong? Did galaxies form more quickly than our models allow? Or is something even deeper missing from our understanding of the universe? Rethinking the Big Bang. What the JWST might be telling us. Introduction. We examined Dr. Michio Kaku's thoughts on the stunning discovery by the James Webb Space Telescope: 6 enormous galaxies that seem to exist far earlier in the universe than current models predict. We'll dive deeper into the scientific tools used to make such discoveries, explore potential sources of error, and confront the possibility that our current understanding of the Big Bang may need a serious rethink. How do scientists measure cosmic distances? One of the primary tools used to determine the age and distance of cosmic objects is redshift. This refers to how light stretches and shifts toward the red end of the spectrum as galaxies move away from us, due to the expansion of the universe. It's a bit like hearing a siren from a moving ambulance. As it approaches, the sound is higher pitched. As it moves away, the pitch lowers. Light behaves similarly. When a galaxy recedes from us, its light shifts toward red, and the amount of redshift gives astronomers a way to estimate how far away it is, and how long ago that light was emitted. These redshift values are then converted into estimates for how old a galaxy is and how early it formed in the universe's history. Where things might go wrong, while redshift is an incredibly powerful tool, it isn't foolproof. Even small inaccuracies in redshift measurements can lead to large errors in estimating a galaxy's age or size. With these 6 newly discovered galaxies, some scientists are asking, could the measurements be off? Could we be mistaking something closer or less massive for something ancient and vast? That's a valid question, and it's being taken seriously. Astronomers are reanalyzing the data and refining their calculations. But if the redshift values are accurate, then these galaxies truly did exist much earlier than we thought, and that's where things get truly groundbreaking. A crisis for the Big Bang Theory? The Big Bang Theory has long been the foundation of modern cosmology. It explains how the universe expanded from a singular point roughly 13.8 billion years ago. It is supported by extensive evidence: cosmic background radiation, the abundance of light elements like hydrogen and helium, and the expansion of galaxies in all directions. But this discovery could be its first major crack in decades. If these universe-breaker galaxies are as old and massive as they seem, then our model of early cosmic development may be missing key factors. Either galaxies formed faster than we expected, or the early universe was structured in ways we don't yet understand. What this means for science, Kaku and many other scientists are reminding the public that this is exactly how science works. We build models based on evidence, but we remain open to new data. And when new data appears, it can force us to revise our theories, even those we once believed to be well established. In fact, history is full of such moments. People once believed the Earth was flat, or that the Sun orbited around us. Only through better tools and more accurate observations did our view of the universe evolve. Today, we are witnessing a similar shift. Conclusion: the discovery of these 6 massive galaxies is not just a fascinating curiosity, it may be a signal that our cosmic story is far more complex than we ever imagined. Whether it leads to a revision of the Big Bang Theory, an update to our galactic formation models, or the birth of entirely new theories, one thing is certain. We are standing at the edge of a new era in astronomy and physics. Thank you for watching. If you found this topic as fascinating as we did, please like, share, and subscribe for more content on space science, astrophysics, and the future of our understanding of the cosmos. And be sure to leave a comment below. Do you think the Big Bang Theory will survive this discovery, or are we witnessing a scientific revolution? We'll see you in the next video.